Okay, today I'll continue the class permutation combinations. So in previous class I discussed about fundamental principle of multiplication and fundamental principle of addition. Okay. So before starting the class, I request you that you listen the class till to the end so that you can understand the concepts clearly. So don't skip any part of this class. And if you like this lesson, at the end subscribe my channel and hit the like button. Okay. Now I'll define what is a permutation. In fact, permutation, roughly speaking, is an arrangement of some objects in a particular order. That is the permutation. So what is permutation? What is a permutation? Permutation is nothing but, I say simply, it is an arrangement. I say simply it is an arrangement. So remember, permutation means simply arrangement. Arrangement of objects, like arrangement of numbers, arrangement of letters, arrangement of balls, or arrangement of persons. So such type of arrangements we are going to count. How many arrangements possible. How many arrangements possible we are going to count. So permutation is what? Arrangement. Maybe numbers, arrangement of maybe letters, maybe persons. Okay. So formal definition is what? The definition is arrangement of objects. Arrangement of objects taking some or all objects. So here I say some or all. Why? Because in every problem of permutations there will be some set of distinct objects from which we have to use some of them or all of them. So it depends on the data, that is depend on the question. So that's why I am speaking arrangement of objects taking, you may take some of them or you may take all of them. All objects from what? Given distinct objects. So here this is important, distinct objects, from given distinct objects in a particular order. So I am saying here in the beginning I am using the word distinct. Later we are going to find out whenever the given objects are not distinct, how to find out the number of arrangements, how to find out number of permutations. We are going to do that also after completing this concept. Whenever distinct objects given to you, how to find number of arrangements, first we will see, then later we are going to find out how many arrangements are possible whenever in the given objects similar objects are also there, not all distinct. In that case also we can find number of permutations. But first we have to learn how to find out number of arrangements whenever the given objects are distinct. So I think you understood what is permutation. Permutation is what? Simply an arrangement of objects. Simply an arrangement of objects, whether the given objects are distinct or maybe some of them are similar, still we will say that is an arrangement only. Okay, that arrangement is what? Permutation. Okay. So now I'll derive a formula. To find out number of permutations. Suppose there are n distinct objects given to us. Suppose there are n distinct objects given. Okay. So from this n distinct objects, you have to find out how many arrangements possible. How many arrangements possible. So number of arrangements you have to find out. Okay, in that you have to use R objects only. So by taking R objects, how many arrangements or how many permutations are possible, we have to find out. Now you see here here the use of fundamental principle of multiplication. Here we apply the fundamental principle of multiplication. Now, how many objects given to us? How many objects? N distinct objects. So once again I want to stress this word distinct. So whatever the rule I am going to derive now, the formula I am going to derive now will be used whenever the given objects are distinct only. If the given objects are not distinct, we cannot use the formula which we are going to derive now. Right. So n distinct objects given. How many objects we have to use here? How many objects we have to arrange here? R objects we have to arrange. So that means you can think of there are R places. So you can think of there are some places in number, they are R places. So this is first place. Okay. Now this is second place. This is third place. Up to so on. Suppose this end place is what? Rth place. Now here we have to arrange R objects by taking from available objects are how many? N distinct objects available to us. You have to arrange how many? R objects in these R places. Now you see, I go with from the first place. Now here for the first place, how many choices you have? Can you think how many choices we have for the first place? How many objects given to you? N distinct objects. For example, you see, I'll give you something objects, 4 objects I'll give you. Let us suppose some fruits, banana, okay, and something say apple, okay, banana, apple, orange, and pomegranate. 4 are there. Out of 4 apples, I have to arrange here out of 4 fruits, we have to arrange 1 fruit in the first place. How many choices we have? So you may use banana, or you may use apple, or you may use orange, or you may pomegranate. So 4 choices. Any one of that fruit will be placed in the first place. So we have 4 choices in the initial stage. In the initial stage, we have 4 choices because of 4 objects available to us. Now here, how many objects we have? N distinct objects, out of which 1 object we can place here in the first place. So how many choices we have? N choices. Any one of the object you can arrange in the first place. Now after using the 1 object from N distinct objects, now one is already placed here. So we left with how many objects? N minus 1. 1 object is less. Okay, comparing with the initial stage, because of you used 1 object here. So how many objects left with us? N minus 1 objects. N minus 1 objects left with us. Now for the second place, any one of the object from the remaining can be arranged here. So how many possibilities again? N minus 1 choices. So whenever you used 1 more object, so 1 more less. Therefore how many objects left now? N minus 2 objects are remained. N minus 2 distinct objects are remained. So for the third place, we have how many choices? N minus 3 choices. For fourth place, like this if you continue, N minus 4 choices. For see first place, N choices. Second place, N minus 1 choices. Now here you have to notice how much number you are subtracting from N. So whenever you say second place, you are subtracting 1. N minus 1 choices. Whenever you say third place, here I did something mistake, N minus 2. Because of N minus 1, after that N minus 2. Whenever the place is 3, choices are N minus 2. Whenever place is 4, the choices are N minus 3. Whenever place is 5, the choices are N minus 4. Whenever the place is 6th place, how many choices? N minus 5. Now once again you observe, whenever place is second, you are subtracting digit 1. Whenever place is third, you are subtracting digit 2. Whenever place is 4, you are subtracting digit 3. Whenever place is 5, you are subtracting 4. Whenever place is 6, you are subtracting 5. So can you guess for the 7th place what are the choices? For the 7th place, the choices are N minus 6. The choices are N minus 6 choices. So keep on continue like this. Can you guess for rth place how many choices left? How many choices for the rth place we have? It's very simple, because of second place minus 1, third place minus 2, fourth place minus 3, fifth place minus 4, sixth place minus 5, seventh place minus 6, eighth place minus 7. Therefore rth place. What is rth place? What you have to subtract? Whenever you say 6th place, you are subtracting 5. So 1 less than the place number. 6th place 5 subtracted. 7th place if I say 6 subtracted. 8th place if I say r minus 1, you have to subtract r minus 1. So what is that? N minus r, minus into minus, plus 1. N minus r plus 1. So n minus r plus 1 choices we have for the rth position. So now see, what is our main job? The main job is what? The main job is filling all these places. Now the job is finished. First I did this one. Second I arranged the second place. Then third I arranged the object in the third place. So one by one consecutively I am doing sub jobs. So whenever you do consecutively some jobs in some particular number of ways, what we will do? According to fundamental principle of multiplication, we will multiply them. So number of choices, n choices, into n minus 1, into n minus 2, into n minus 3, up to rth place is what? Last one is n minus r plus 1. So the total number of ways of arranging r objects is what? N into n minus 1 into n minus 2 into n minus 3 into up to so on n minus r plus 1. So I think you understood. Okay. Now we are going to simplify this. Okay. We got actually how many arrangements are possible using r objects whenever n distinct objects given to you. We got the result n into n minus 1 into n minus 2 into n minus 3 into up to so on n minus r plus 1. See what is that result? N into n minus 1 into n minus 2 into up to so on n minus r plus 1. Okay, so this is the result. What is the result? Number of permutations or what? Number of arrangements. Number of arrangements possible using r objects from given n distinct objects. The result is n into n minus 1 into n minus 2 into up to so on n minus r plus 1. Why I multiplied? Because of to complete this job, you have to perform all these jobs one by one. So whenever you do some jobs one by one consecutively, so the number of ways of doing the total job will be equals to n into n minus 1 into up to so on n minus r plus 1. So keep in mind, okay, I'll write that again now. I'll simplify that into a particular form. So what the result? What is the result we got? The number of arrangements is what? N into n minus 1 into n minus 2 into n minus 3 up to so on n minus r plus 1. Okay, you see. So what I got, I will write now. The number of arrangements, of R objects. How many objects? R objects. From how many objects given to us? N distinct objects. So this is underlined important point, important thing. N distinct objects. So what I got? The result is what? N into n minus 1 into n minus 2 into up to so on n minus r plus 1 I wrote, or simply I okay n minus r plus 1. This is the number of arrangements possible. Now you see, n is what? Number of objects. So obviously it's a positive integer. Number of objects is a positive integer, right? N is a positive integer. So what you are doing? You are removing one from that, subtracting one. Then again you are subtracting one more, like that you are continuing. So for example, if I start with, okay, 5, let us suppose I started with 5. 3 places, so 4 into 1 more less, 3. So 5 into 4 into 3. So this is the situation we have. Okay, what is the meaning of this? Whenever 5 distinct objects given to you in 3 places. So for the first place, 5 choices. For the second place, 1 less than that, 4 choices. Then 2 less than that, because of 2 objects will be used in the first 2 places, 3 choices. So 5 into 4 into 3 will be the result. What I will do, I multiply with 2 into 1 and divide with 1 into 2. Okay, so I am dragging that number till to 1. Okay, I am dragging that number up to what? 1. So whatever the numbers I am writing extra as a multiplication, I am going to divide. So what I have to do? Subtract one more like that up to where? Whenever you reach 1, you have to terminate your expansion. Now you see. So this is equals to n into n minus 1 into n minus 2 into up to so on n minus r plus 1. 1 less than this. 1 we have to subtract. Whenever you subtract 1, this one will be removed, n minus r. And one more you subtract, n minus r minus 1 up to so on. At the end you are going to get 2 into 1. 3, then one more less 2, then one more less 1. Divided by, so what I multiplied here from 1 to n minus r, this I extra multiplied, so I will divide 1 into 2 into 3 into up to so on up to where n minus r. So keeping in mind that you know about the factorials, I am supposing here that you know about the factorials. So if you don't know about the factorials, just you comment below and I'll make a video lesson for you, those who are unable to understand these factorials. Okay, right. So now this is equals to 1 into 2 into 3 into 4 into, like that it will be continued up to where? Up to n. So what is this? Product of first n natural numbers. So product of first natural numbers, n natural numbers is denoted by what symbol? N factorial. So there is n factorial. So just simply one example I will give you. If you don't know what are the factorials, 1 into 2 into 3, we say it is 3 factorial. If you say 1 into 2 into 3 into 4, we say it is 4 factorial. 1 into 2 into 3 into 4 into 5, we say it is 5 factorial. So product of natural numbers is written by the factorial symbol. Okay, so that's why 1 into 2 into 3 into 4 into up to so on, up to what? N, therefore n factorial. Now you see the denominator. What is the denominator? 1 into 2 into 3 into 4 into 5 into up to so on where? N minus r. So if I stop 1 into 2 into 3 into 4 into 5 factorial. 1 into 2 into 3 into 4 into 5 into 6 into 7 if I stop to 7 factorial. So 1 into 2 into 3 into 4 into up to so on n minus r. So it is n minus r factorial. So n minus r factorial. Product of natural numbers. Product of consecutive natural numbers. Right. So this is n factorial by n minus r factorial is the simplified form of this. What is that? The number of arrangements whenever you take r objects and available objects are n distinct objects given to you. You want to arrange r objects. In that case, how many arrangements are possible or how many permutations are possible? This is the result. N factorial by n minus r factorial. N factorial by n minus r factorial. Okay, now you see, I'll give a notation, a standard notation for n factorial by n minus r factorial. I am going to give you a standard notation for n factorial by n minus r factorial. What is n factorial by n minus r factorial? Number of arrangements. Nothing but number of what? Permutations. So number of permutations. P. I use the letter from permutations P. And how many objects given to you? N objects. So I'll write that n here. So it's a standard notation, right? Yeah. How many objects you want to use? R. So R I'll keep here. So this is the notation NPR. What NPR stands for? NPR stands for number of permutations or number of arrangements by taking R objects from given n distinct objects. Keep in mind, these NPR will be used, this formula NPR or notation NPR, which is equals to n factorial by n minus r factorial, will be used whenever given distinct objects. N given distinct objects. So you want to use how many? R objects. So therefore what is NPR now? The NPR formula is what? N factorial by n minus r factorial. NPR is equals to n factorial by n minus r factorial. So remember how many objects given to you and how many objects you want to use. How many objects given to you, that will come in the place of n. How many objects you want to use in the arrangement, that will come here. NPR, number of permutations or number of arrangements. Now a simple problem based on this formula NPR. Okay, we'll see one simple problem, just direct application of the formula NPR. For example, now there is a word given to you. Okay, there is a word given to you, like something equation I will take. Okay, this is the word. Now the question is, reshuffle all the letters randomly in all possible ways. Rearrange the letters in all possible ways. So how many arrangements are possible? That is the question. Now first you have to observe whether the given objects Here objects means letters actually. So given letters are distinct or not. They are distinct or not. First we have to see. E is here. So it's there only once. Not repeated. Q not repeated. U not repeated. A not repeated. So in this word, each and every letter appeared only once. Only one time. So therefore they are all distinct. So how many letters given to you? How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters given to you. So these 8 letters, how many ways you can arrange? Now you see in this question is not mentioned how many letters you have to use. How many letters we have to use, it is not mentioned. So that means you have to use all the letters. So 8 letters given to you, you have to arrange 8 letters. So 8 letters given to you, you have to arrange 8 letters. So that is 8p8. For example, so we will, this you can calculate using the formula. What is the formula? NPR, this is N, this is R. What is NPR? N minus R factorial, N factorial by N minus R factorial. So what it will become? 8 factorial by 8 minus 8, 0. 0 factorial is 1. So that is equal to 8 factorial. Remember 0 factorial is 1. Okay. So 8 factorial by 1, that is equal to 8 factorial. So it's finished. How many arrangements possible means 8 factorial. So if you want to calculate what is 8 factorial? 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. That is the value. So it's a big number. Okay. So if you want, you can calculate it. Now instead of saying all the letters, if I say how many 4-letter words we can form using the letters of the word equation, how many 4-letter words can be formed? The question is, given letters are 8. How many letters you have to use? 4. So 8 letters given to you, 4 letters you want to use. So answer is what? Simply 8p4. So top place we write how many objects are available to us, and here bottom place we write how many objects we want to use. So he asked 4-letter words. So therefore the answer is 8p4. So you can use once again formula 8 factorial by 8 minus 4 factorial and 8 factorial. If you want, you can calculate what is 8 factorial. 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 divided by 8 minus 4, 4 factorial. 1 into 2 into 3 into 4. This will be cancelled and you can calculate this. Okay, what is that? 5 6 is 30 into 56. So this you can calculate if you want. So this is the simple, very basic problem actually on permutations on NPR formula. So keep in mind what is NPR. So once again, what is NPR? N is what? Number of objects given to us. R is what? Number of objects we want to use. P stands for permutations. And one more thing you have to keep in mind is what? N objects given to you, that all R should be distinct. All objects should be distinct to use this NPR.